Good evening. Today's quote is that which does not kill us makes us stronger. That which doesn't kill us makes us stronger. Today's word, which is not commonly used now, is debonair. Someone debonair is charming, confident, stylish, and elegant. They have good manners and they probably look good too. Yesterday we discussed about types of relations. Let A be a non-empty set, then a relation R on A is said to be reflexive if A is always related to A for all small a belonging to capital A. It is symmetric if A related to B implies B related to A for all A and B belonging to set A. And it is said to be transitive if for all ABC belonging to set A, if A is related to B and B is related to C, that implies A is also related to C. A relation R on set A is said to be equivalence relation if it is reflexive, symmetric, and transitive. Now we start solving sums. I think exercise 5.2, ninth, we have completed first part. Now second, see all these sums are important. Let me write that relation first. How relation R is defined? An ordered pair AB such that A and B belong to set of natural numbers and A plus B is even. Okay. So let ABC, we need C for transitive property. Let ABC belong to set of natural number. Now A plus A plus A equal to 2A is definitely even. You may ask me, but A can be an odd number. Yes, but odd number multiplied by 2 is also even. So this is definitely even. I hope you are getting this. Therefore, A is definitely related to A for all. This is inverted A and it stands for all, for every. For all A belonging to N. Right down. So R is what? Reflexive. So R is reflexive. Then we have to examine for, see, every relation need not satisfy all the three properties. We are in fact asked to verify that. Okay. Now, next one, let A R B. What do you mean by A R B? A is related to B. Means what? A plus B is definitely even. Now, if A plus B is even, B plus C is also even. B plus A is even, right? Because addition is commutative. Therefore, B related to A. That is, ARB implies B RA for all small a belonging to capital N. In fact, not only A, but I should say A and B. So can I say that R is symmetric? So R is symmetric. Now, third part is interesting. Let A R B and B R C. So A plus B and B plus C are even, because when we say that A is related to B, clearly A plus B is even, B related to C, so B plus C is even. Let A plus B equal to 2m. Why I am saying 2m? Because every even number is 2 times, right? And B plus C be 2n, where m and n, they are natural numbers again. Okay. Now, next part. So A plus C equal to. Now this is interesting. What is A plus C? It is nothing but, I write this. Before that, let me explain this part. A plus B plus B plus C. What is A plus B plus B plus C? It is nothing but 2m plus 2n. But I am interested in knowing whether A plus C is even or not. So rearrange the terms. Can you tell me what is A plus C from this? It is 2m plus 2n. Now on left hand side, it is not only A plus C, but it is A plus C plus 2b. I want A plus C only on left hand side. So I have to bring 2b to right hand side. So take 2 common. So m plus n minus b. Even number. This means A is related to C. That is, A related to B, B related to C implies A related to C for all A, B, C belonging to what? Belonging to capital N. So what is the conclusion? R is transitive. A good student may add that this is an equivalence relation. Third one, R set of ordered pairs AB. AB belong to N and A divides B. Okay. Now, clearly A divides A, obviously. So, R is reflexive. A is related to A for all A belonging to N. Now, to examine the symmetric property, to examine whether relation is symmetric or not, we have to consider particular values. Suppose we consider A equal to 4 and B equal to 8. Now you may ask me, why B equal to 8? Why not 5, 6, 7? Because we have to say that if A is related to B, so 4 divides, does it divide 5? No. 6? No. 7? No. 8? Yes. So 4 divides 8. Means what? A is related to B. Now does 8 divide 4? No, it doesn't. So ARB does not imply BRA. That is B. Now this is the convention. B not related to A. So clearly the relation is not symmetric. I hope you are getting this. Now examine for transitivity. So let A are B and B are C, where A, B, C are natural numbers, right? What does this mean? So A divides B, B divides C. This clearly indicates that B is multiple of what? A, and C is multiple of B. Simple. What are M and N? They are natural numbers, naturally. So what is C? It is nothing but Bn, but B is Am. So Amn, that is Mn into A. So C is a multiple of A, and therefore I can say A divides C also. That is A related to C. So the conclusion is A R B and B R A implies, I'm sorry, I should say not B R A, but I should say B R C implies A R C for all ABC belonging to capital N. So conclusion is R is transitive. R is transitive. Fourth one, R is relation set of ordered pairs AB, A and B are natural numbers, and A square minus 4AB plus 3B square equal to 0. That is what A square minus 4AB plus 3B square equal to 0 means. A minus B into A minus 3B 0. So A is B and A is 3B. Now A equal to A. So A is definitely related to A. You can replace B by A. See, yes, A square minus 4A square plus 3A square equal to 0. Right? So A is related to A for all A belonging to N. That is, R is reflexive. Right now. Now we have to consider particular values. Let A be 27 and B equal to 9. So I have taken A as 3 times B. Okay. So A equal to 3B. Therefore, A is related to B. Now, next part is interesting. B is not equal to A. B is not equal to 3A also. Therefore, B is not related to A. I hope you are getting. See, can I say B is related to A? For that, first number should be equal to second number. But no, 9 is not 27. Or first number, first element in ordered pair must be 3 times the second. Is 9 3 times 27? No. So B is not related to A. So A or B does not imply B or A. So the conclusion is R is not symmetric. Actually, presentation is important. So it is better if we say A and B belonging to N. R is not symmetric. It's quite logical. See, this is not at all difficult. A is 3B, B is 3C, like that. So If I take A as 27, B has to be 9, C has to be 3. You may say, can we take A as 81? No problem. Then in that case, B will be 27 and C will be 9. Let me explain. For transitive property, let A be 27, okay, B equal to 9 and C equal to 3. Here A is 3B, so A is related to B, okay. B equal to 3C, so B is related to C. I hope you are getting this. But A is not equal to C and A is not equal to 3 times C. See, there are two factors. I hope you are getting this. So we got A equal to B, A equal to 3B. Now we have to examine whether A is related to C. So we have to check whether A equal to C. No. Is A 3 times C? No. Therefore, conclusion is A is not related to C. Right? So A related to B, B related to C does not imply A related to C, and therefore R is not transitive. Fifth one, R ordered pairs AB. A is a sister of B. A and B belong to set G, which stands for set of girls. Now, no girl is her own sister. So A is not related to A. So R is not reflexive. Let A related to B, means A is sister of B. So in that case, B is sister of A. So B is related to A. Therefore, A related to B implies B related to A for all A and B belonging to set of girls. So I can say that R is symmetric. Right now. Let A related to B and B related to C. Means what? A is a sister of B and B is a sister of C. Therefore, A is a sister of C, that is A related to C. Therefore, ARB, BRC implies ARC for all ABC belonging to G. Therefore, R is symmetric. Right now. Actually, I should have written here R is transitive. Not reflexive. Now this is correct. Sum number 6 are ordered pairs AB. Line A is perpendicular to line B in a plane. In the textbook, it is place, but in place of place, you have to read plane. Plane. Now, no line is perpendicular to itself, so A is not related to A, so it is not reflexive. Let A R B means what? A is related to B, that is A is perpendicular to B. Now, if A line A, it is better if you write line A. If line A is perpendicular to B, is line B perpendicular to line A? Yes, it is. So B is also related to A. Therefore, R is symmetric. Okay. Let A related to B and B related to C. That is line A, you should write line A perpendicular to B, line B perpendicular to line C. See, it is like this. So line A perpendicular to line B, perpendicular to line C. So this is A, this is B, this is C. Therefore, line A is parallel to line C. Therefore, A is not related to C. See, in exam, you have to write in detail that, okay, I'll write that. Example is better than precept. So ARB, BRC is not implying ARC. So R is not transitive. Right now. Now, sum number 7. R ordered pairs AB such that A and B belong to R and A is less than B. Now, can I say A is less than A? No, A is equal to A, right? So clearly R is not reflexive. Now consider particular cases. A equal to say 2, B equal to 4. You could have taken A as 22,000 and B as 22,001, right? But A has to be less than B. So A is less than B, right? But if A is less than B, does B less than A? No. So even if A is related to B, B will not be related to A. So it is not symmetric. Now if A is less than B, B is less than C, clearly A is less than C. You can take example. 10 less than 7, 7, I'm sorry, 3 less than 7, 7 less than 10, so 3 less than 10, right? So it is transitive. So not reflexive, not symmetric, but transitive. And the last one, A, B ordered pair such that A and B are real numbers, A less than or equal to B cube. Suppose A is -2. So what is A cube? -8. Now -2 is greater than -8. Okay. And therefore A is not less than or equal to A cube. So it is not reflexive. This is not difficult. Suppose A is 1, B is 2. So that what is A cube? 1, B cube 8. Now A less than B cube, that is A related to B. But B is greater than A cube. So A related to B, but B is not related to A. So R is not symmetric. Suppose A is 8, B is 2 and C is 1.5. Now A is B cube, so A is related to B. Now C cube is 1.5 cube, that is 3.375. So B is less than C cube because I have taken B as 2. Okay, so B is related to C, but note that A is greater than C cube. So A related to B, B related to C does not imply A related to C, and therefore R is not transitive. Now miscellaneous exercise 5. First question, select the correct answer from the given alternatives. First one, for the set A, B, C, D, E, the correct statement is C, A belongs to capital A. Second is interesting. If AN, all X such that X belongs to N, then the set 6N intersection 8N. So means you have to find what? LCM of 6 and 8, that is 24N, right? Which is given in option D. Third one, if set A is empty set, then N of P of A is. Let me explain. N of A equal to 0. So what is N of P of A? P means power set. It is always 2 raised to N, 2 raised to 0, that is 1. So it is N of P of A? 2 raised to 1, that is 2. Finally, N of P of A is 2 square, that is 4. So correct option for sum number 3 is D, Delhi. Right down. Fifth one, if the two sets A and B are having 43 elements in common, then the number of elements common to each of the sets A cross B, B cross A is. I have taken simple example. So in A cross B, there are 6. In B cross A, there are 6, of which 4 are common. So 2 into 4, that is 2 square. So if 43 are common, then 43 square is the correct answer. That is A. Sum number 6. 2x plus y is 41. So in that case, can we say that 2x plus x is 41? Not necessarily. We can verify by taking particular example. So it is not reflexive. Then 2x plus y is 41 does not necessarily mean 2y plus x equal to 41. Right? So it is not symmetric. Suppose x is related to y. So 2x plus y is 41. Y is related to z. So 2y plus z is 41. That doesn't mean that 2x plus z equal to 41. We can in fact consider a particular example and verify that transitive property is not applicable. Rather, R is not transitive. So correct option is D, Delhi, for sum number 6. Seventh, the relation greater than in the set of natural numbers is. Now 14 greater than 7. Is 14 greater than 14? No. Or if 14 is greater than 7, is 7 greater than 14? No. So this is not reflexive. This is not symmetric. But if 14 greater than 7, 7 greater than 3, then is 14 greater than 3? Yes. So it is only transitive. Correct option is C. Sum number 8. A relation between A and B is subset of A cross B. So correct option is D, Delhi. Now 9th is important. Let me explain. Actually, in my opinion, none of the options is correct because it is reflexive and transitive. I hope you appreciate this. See, xy, what is given in 9th? They say xy is x square. Is x into x square? Yes. So it is reflexive. Now take x equal to 0, y equal to 1. So xy is x square. But 1 into 0 is not 1 square. So clearly it is not symmetric. But we can prove that it is transitive. X is related to y is related to z. So xy is x square, yz is y square. So xy into yz is x square y square. Okay. So I can say that xz is x square. I have cancelled y, in fact y square. So I have to write if y is not equal to 0. Now, when we say or for it to be transitive, it should be true for all, right? And therefore, we are doing some number 9. Okay. So if y is 0, then xy equal to x square. So x has to be 0, right? Because we have said that x is related to y. Now when x is 0, what is x into z? 0, because x is 0. Can I say 0 is 0 square? Yes. So it is transitive also. And therefore, option should have been reflexive and transitive, but it is not given. Last, in A cross A, there are how many? 3 square, that is 9 elements. And what is asked? Number of distinct relations. Every subset is a relation. So 2 raised to 9. So correct option is D, Delhi.